Hello and welcome to Virtual Laboratory of Mechanics of Solids. I have opened the web browser and used this link, and you can open it too. This is the main home page where you read about what Virtual Laboratory is. It contains 4 experiments, namely tension, compression, transverse, and shear tests. Well, all these 4 experiments will be performed by a very important machinery, and that is called universal testing machine. We have tried to explain you the mechanism. How do you operate for your experiments?
To apply
It contains
force
3
due to
heads,
hydraulic
namely
pressure
upper head,
of
middle
oil.
head, and lower head. Middle head is for the adjustment as per the specimen, whereas lower head and upper head acts together by mean of oil pressure, as you have seen. Now that you have understood the mechanism of universal testing machine, let's jump into our first experiment, and that is compression test. We have put objective relevant IS code. How do you prepare the specimen for different type of material, that is ductile and brittle, as per the aspect ratio. We have also prescribed the procedure to be followed in real laboratory, and here we have the experiment. You already know the mechanism of universal testing machine, so let's select ductile material with aspect ratio, that is length to diameter ratio less than 2. Now for compression, where do you put the specimen? Of course, you will put it into lower head. Adjust the middle head, pressing yellow button as per the specimen, and now apply the load. Press the green button and observe the failure pattern. See, it's bulging. Why? Because it's ductile and its aspect ratio is less than 2. And this is the failure pattern for any such ductile material, whereas aspect ratio is less than L by 2. See, it is bulging. Well, this was about a ductile material having aspect ratio less than 2. What about same ductile material but length to diameter ratio is more than 2? You can see the length is higher. Adjust the middle head and apply the load. Now observe the failure pattern. It is not bulging, it is buckling, it is bending from the center, and this failure pattern is called buckling. It happens for a ductile material where L by D, length to diameter ratio, is more than 2. Now we have third kind of material for compression test, where we have a brittle material. Now you observe the failure pattern. It will not take much load, and it will have a hairline crack at 45 degrees at the middle of the specimen, and that's how a brittle material fails under compression. Let's look at how should we record our observations in real laboratory and how our specimen looks like before and after. So first you see is field specimen bulged and buckled, and second you see is this is the buckled, first is bulged. Yeah, so that's how it works. And here are a few questions to test yourself. Don't worry, I am not gonna ask for results. Now that we have understood compression test, let's jump into tension test. This is a ductile material, but since we are testing it for tension, we will place this specimen in upper head. We will adjust the middle head as per the specimen, and when we apply the load, the upper head will stretch the material upwards. Now observe the failure pattern. It's cup cone failure. See? And there's this amazing graph, amazing curve that is called stress strain curve for ductile material. Now what if we take a brittle material for tension? Let's put it in the upper head. Let's adjust it by pressing yellow button and apply the load. When we'll apply the load by pressing green button, observe the failure pattern and the graph as well. It just fails at a very low load. And the failure pattern is completely different. It just breaks at 45 degree at the middle approximately. So now that we have understood how it fails and what it takes to fail, these are the observation tables, and this is a brittle material before after the failure. This is the ductile material before after the failure. Real photographs from the laboratory. And now, as always, we have some questions for you. Answers at your own pace and time and interest. We are not gonna ask you for the answers. After tension and compression test, let's look at shear. You can go through this wall data that we have put here about objective, relevant IS codes, how do you prepare a specimen, procedure to be followed in laboratory, and we will jump to the experiment, which is an interesting thing. Now remember, when we perform shear test, there are two type of shear tests that you can perform. One is single shear, one is double shear. We will first perform single shear. Now to perform any kind of shear test, you have to prepare a shear attachment, wherein this is a middle wedge. There's this one ring that will put vertically, and then we'll place the specimen horizontally. Now what will happen is, okay, let's just put this shear attachment in the lower head, and now you will understand how it feels. Just observe. Or specimen is horizontally placed, and it will feel like this. It will feel into two parts, one longer, one shorter. And why? Because it feels near the wedge. We are applying shear load. You know what it means, right? Now let's test it for double shear. So when we are preparing the shear attachment for double shear test, we will place rings on both the sides of shear attachment, and we'll place wedge as always in between. Now through common concentric hole, we will place our specimen horizontally like this, and again for shear we will place it in compression zone, that is our lower head. So let's place it there. Let's adjust the middle height for the specimen height, and we will apply the load. See the failure pattern. It is actually breaking in three parts. Two cuts, three parts. Why? Because it was double shear, two rings, remember? This is the observation table, a sample observation table. And this is how a failed specimen look like for single and double shear test. Okay, these are the questions for yourself. Oh, this is about us. We actually, me and my colleague Rinkesh had developed this experiment under the guidance of Dr. P.V. Patel sir and Professor Digesh Joshi sir as a part of our